Hi, this is your host Habibur Rahman, and welcome to my show Azure Essential Series. In today's episode, we will talk about Azure Notification Hubs. Azure Notification Hub is a scalable cross-platform push notification service provided by Microsoft Azure that enables you to send targeted and personalized notifications to millions of mobile services across various platforms including iOS, Android, and Windows. It simplifies the process of sending push notifications by offering a unified API that allows developers to broadcast notifications or send personalized messages to specific users, devices, groups, or user segments. So let's start this. This is the agenda for today episode. First of all, we will have introduction to Azure Notification Hubs. We will discuss about key components of notification hubs. Then we will talk about tagging and segmentation of notification. We will also explore the supported notification platforms. We will have discussion on the benefits and the use cases of Azure Notification Hub. So this is your host Habibur Rahman. I am two times C Shop Corner MVP, Microsoft Certified Solutions Developer, and currently working as a lead software developer at Now Software. First of all, we will talk about key components of Azure Notification Hubs. When working with Azure Notification Hubs, three key components you need to understand are namespaces, hubs, and registrations. So here is a brief overview of each thing. Basically, a namespace in Azure Notification Hub is a container for one or more notification hubs. It provides a way to group multiple hubs together under a single management domain. The main purpose of namespace is to organize and manage your notification hubs, especially when you have multiple applications or environments like development, testing, and production. A typical use case would be a company that manages multiple apps, each with its own notification hub, but all grabbed under a single namespace for each of management. Then we have hubs. A hub is a single instance of Azure notification hubs that enables you to send push notifications to various platforms such as an iOS and Android, etc. The purpose of notification hubs acts as a central point to send push notifications to mobile devices. It abstracts the platform specific APIs and handles the complexities of multiple push notification platforms. For instance, an app named News App could have a single notification hub to manage and send notification across both iOS and Android platforms. And then we have registrations. A registration is a device specific entry in a notification hub. Each device that needs to receive push notification must register itself with the hub. Registrations are used to store device tokens or handles that are required to send notifications to the respective devices. They also include any tags that specify which notifications a device should receive. We have two types of registrations. With native registration is used when you want to send platform specific push notifications, and template registration is used to define a payload template for notifications that allows for localization and personalization. uh, Next we have tagging and segmentation. Basically, this is a very powerful feature in Azure Notification Hubs that allows you to deliver targeted and personalized push notifications to specific groups of users or devices. These features enable developers to enhance user engagement by sending relevant notifications to users based on their preference, behavior, location, or any other criteria. So in Azure Notification Hub, tags or labels that you can assign to device registrations to group devices or users with similar interest or characteristics. Tags allows you to send notifications to specific segments of your user base without changing the app code. And few key points about tagging are they provide flexible grouping, and tags can be any string value, making them highly flexible. Tags can represent a user's location, for example, New York, or preferences, sports, or device type, which is iOS. So you can tag anything flexibly in Azure Notification Hub. And then we have dynamic updates. Tags can be updated dynamically as user behavior or preference changes. Then a single device can have multiple tags, enabling complex and high customized segmentation. For instance, a user interested in both technology and finance can receive notification relevant to both topics. We have targeted notifications. By using tags, you can send notifications to all devices with a specific tag. For example, sending a notification only to users interested in music, or only the device tags with VIP users. So this is how you can specifically target the user for notifications. Next, we have segmentation. Basically, segmentation is the process of dividing your user base into distinct groups on specific criteria, such as demographics, behaviors, or preference. In Azure Notification Hubs, segmentation is achieved using tags, allowing you to tailor your messaging strategy to different users groups. In personalization, segmentation allows you to send personalized notification that cater to the unique interest and needs of different user groups. By sending relative content, you can increase user engagement and satisfaction. Segmentation can be used on user behavior base, such as in-app activity or purchase history. Then we can also do geo targeting. Segments can be created based on geographic location to send region specific notifications, like local news, weather updates, or localized promotions. And very important thing, life cycle marketing. Segmentation can be used to create user segments based on their life cycle stage. For example, new users, returning users, and inactive users. So this is how tagging and segmentation works. Next, we have supported notification platforms. Azure Notification Hubs support a wide range of notification platforms, enabling you to send push notifications to users across various devices and operating systems. Here are few key supported notification platforms. First of all, we have Apple Push Notification Service. APNS is the service provided by Apple for sending push notifications to iOS and Mac OS devices. Azure Notification Hubs integrate with APNS to allow developers to send notification to Apple devices. Then we have Google Notification Service, which is Firebase Cloud Messaging. We have FCM, which was V1, and we have GCM, which is current working version. So basically, FCM, formerly known as Google Cloud Messaging, is a cross platform messaging solution that lets you reliably deliver messages at no cost. Azure Notification Hubs support FCM to send push notifications to Android devices. Then we have Windows Notification Service. WNS is a platform specific service provided by Microsoft for sending push notifications to Windows devices. Azure Notification Hubs support WNS to deliver notifications to Windows Universal Platform apps. We have Microsoft Push Notification Service, which is MPNS. It's an older notification service for earlier versions of Windows Phone. It is generally used for legacy applications still running on Windows Phone. 8.0 or earlier variants. We have Amazon Device Messaging, which is ADM. ADM is a basically notification service provided by Amazon specifically for Kindle Fire devices. Azure notification hubs support ADM to send push notification to these devices. We have browser push notifications. Azure notification hubs support web push protocol, allowing push notifications to be sent directly to web browsers that support push notifications such as Chrome, Firefox, and Edge. These are basically rapid notification service. At the end, we have Bedu Cloud Push. So basically, Beidou Cloud Push is a popular push notification service in China, and it's particularly for Android devices. Azure notification hubs support Beidou Push to deliver notifications to devices registered with Beidou. So these are supported notification platforms by Azure Push Notification Service. And we have benefits of Azure Notification Hubs. And these several benefits are for developers and organizations which are looking to implement push notifications across multiple platforms. First of all, Azure Notification Hub is a cross-platform push notification service which provide a unified API for sending push notifications to multiple platforms such as iOS, Android, Windows, as we have discussed in previous slide. There are platform specific APIs, so you don't have to be worried about APNS or FCM. Azure push notification will handle this for you. We have scalability. Azure Notification Hub is designed to handle massive scale notifications, and it can send millions of push notifications simultaneously to millions of devices. It also provides personalization and targeting. So it supports for tags and templates to target specific user segments or personalized notifications based on user preference. We have dynamic tag management. Basically, tags allows you to group devices and send notifications to specific segments, such as users interested in specific topics or located in a particular geographic area. High availability and reliability. So Azure is basically robust infrastructure providing high availability and reliability for delivering notification. We have global reach with multiple data centers with Azure notification service, and it basically ensure low latency delivery for notifications to users. And there is integration with other Azure services, so you can seamlessly integrate with other Azure services such as Azure App Service, Azure Functions, Azure Logic Apps, and Azure Active Directory. And on second last, we have security and compliance. As you know, Azure supports secure communication channels and integrates with Azure Active Directory for authentication and authorization. So you can ensure handling of sensitive data and compliance with various regulatory standards, making it suitable for enterprise application. At the end, we have cost effective. Azure provides a cost-effective solution with a pay-as-you-go pricing model, which allows you to only pay for the notifications you send. It reduces the cost of business operations with maintaining dedicated push notification infrastructure and provide flexibility to scale up or down based on your usage. Here are few use cases. For example, we have marketing campaigns. So using Azure Notification Hub service, you can send promotional messages, discounts, and offers to targeted customer segments. You can engage your users by sending notification about new content, features, updates, or personalized reminders. We have critical alerts, so you can notify users of critical information such as security updates, weather alerts, or system outages. We can also use push notification for transactional messages. So we can send notifications for important transactions such as order confirmation, payment receipt, or an appointment reminder. So you can use this for many use cases for your enterprises application. Okay, now we will have a hands-on demo on Azure Notification Hub. First of all, we will explore how to create Azure Notification Hub using Azure portal. We will explore different notification platforms. We will set up web push notifications for JavaScript app, and we will send the web push from ASP.NET Core app. So let me share my screen and we can start. Okay, I hope you guys can see my screen now. So I already have opened Azure portal. If you don't have an account, you can sign up with Azure with trial account, or you can use pay as you go subscription model. So after signing up and then open portal.azure.com. So here we can create a new resource. Click on create a new resource. Okay, so now I need to search for Azure Notification Hub. So let's check it manually. Maybe we can find it here, or we can search from. Okay, let's search it. We can say Azure Notification Hub. So this is basically a service from Microsoft. So you can select Azure services only. Let's remove Azure from this. Okay. So this is the Azure Notification Hub service, which is used for broadcasting push notifications to millions of users. So let's click on this. We will create a new instance for Azure Notification Hub service. Okay. So here is create window. First of all, we need to select the subscription. I will select pay as you go. So you can select your trial subscription, or if you are using pay as you go, then you will have the same step. Then we need to select resource group. So I already have one resource group, which is AES, stands for Azure Essential Series. So I will be using this. Then we need to provide namespace details of notification hubs. So as we have discussed already, so this namespace is used for grouping multiple notification hubs. So this is specifically for your grouping purpose. So you can specify any namespace. For example, I can say AES notification hub demo. Okay, so this is my namespace. And here, basically, we create notification hub for our specific app or specific environment. So for example, I am creating this notification hub for my mobile app production environment. So I will say this mobile prod, and then I need to select the location where I want to host this service. So I will be using the default, which is East US. Then we have pricing tier. So let's see this, which pricing tiers are available. Click on change tier and this pop-up will show we have basically three tiers. F1, which is a free tier. This tier includes 1 million pushes with 500 active devices. 500 active devices means 500 devices which are registered with Azure Notification Hub. So if you will cross this count, which is 500, then you have to upgrade your pricing tier. Otherwise, only 500 users will be able to receive push notifications. This is a free service. Then we have B1, which is basic, having 10 million push notifications with 200K active devices. So this is around zero point 0.2 million active devices. So which support this tier. Have standard tier. Inside standard tier, basically we have 10 million include pushes, we have 10 million active devices, and then we have few other services which are bulk operations, scheduled push, and multi-tenancy. But this cost us $200 per month. So these are different services which you can use. For our demo purpose, we will use the free service, which is F1. So select this, which is already selected as well. Then we have availability zones options. Basically, when you will click on this enable availability zones, this will basically duplicate your service on different regions. And if there is any disaster on specific region, your service will be still available from the duplicate region. So this may have additional cost. I don't need this, so I can disable this service and enable disaster recovery. So I will disable this service as well because I'm just doing it for demo purpose. So let's click on next button. This is for tags. So you can tag your Azure services here for billing purpose or for searching purpose. And here is the review summary. So let's click on create button. So Azure is basically initialize my deployment. Currently, deployment is in progress. It will take few minutes. We have to wait for this. Okay, so our notification hub namespace is created. Now it is creating notification hub. So these are two both different things. This is, for example, if you have two mobile apps inside same company, so you can create a single namespace for one company and then different notification hub for different mobile apps. So this is the purpose of namespace in notification hub server. So deployment is still in progress. It have been 2 minutes. It will take a little bit few time, a few more time, but we have to wait for this. Deployment still in progress. Azure is taking a little bit more time for this. Sometimes it takes uh, Okay. Meanwhile, when Azure is trying to deploy this service, we can discuss the web application code which we are going to use for receiving web push notifications on Google Chrome. So let's start from this. Okay. First of all, we have to create service worker.js. So this is basically for receiving web push inside your browsers. As I am not a mobile developer, so I cannot test the mobile push notification. So I will be trying to demonstrate this with web push on browsers. So first of all, you need to create service worker.js application, and inside this service, you have to add few events. First of all, you need to add an event listener for push, and this event will be receiving event data, and then this data is basically in JSON, so it will be deserializing this data into JavaScript objects, and then we need to pass these options to show notification. So whenever you will call this show notification, a new push notification will be showing inside your browser. Okay, then you also need to add another event listener, which is notification click. So whenever any user will click on that notification, the notification will be closed. So this is your service worker JS. So the purpose of this worker is for working inside your browser in background, and whenever a new push notification is received, it will show you that notification. Next step is you need to create an app.js, and first of all inside this we need to register service worker.js. So you whenever we will open our application, this will register this service worker inside your application, and from then this service worker will be working inside background. Then we, after registering the service worker, we need to request permission from the browser. Okay, we need to get notification permission from the browser. If permission is granted, then we will show notification. If permission is not granted, we will not show notification. So okay, if permission is granted, then we need to subscribe to push notification. So whenever permission is granted, we will be using a vapid key. So basically, Vapid is a protocol for sending push notification from servers to web without using any third-party service. So with this, we will not be using any third-party service. So we will register this device to push notification. We will subscribe for that push notification, and if that service is subscribed for push notification, and at the end we will generate endpoint and keys. So these endpoint and keys will be used for sending push notification to this user. As this is a vapid notification protocol, so keys are not managed centralized, so we will have to manage this for our servers. We will only generate these vapid public key from our Azure notification hub service. So this is the code which will be using for showing push notification. This is simple index.html file, and I have included this script inside this application. So I will run this application, and my web application will be subscribed with Azure web push notifications, and then I will send push notification from ASP.NET Core MVC application. So but before that we need to check our Azure notification hub instance. Okay, so deployment have been completed. Let's go to the resource. Sorry for this. Okay, here you can see that notification hub instance have been created. This is the namespace for our notification hub, which is AES and HTML, and this is notification hub. So we can have multiple notification hub inside one namespace. Here you can see that active devices are showing total push, and here it is showing the total limit for push notifications for us. If we scroll down, we can see that we have APNS, which is Apple Push Notification Service. So if you want to send push notification to APNS, so you have to create APNS account, APNS configuration, and then you need to add those details here. So Azure Notification Service will be collaborating with APNS for sending notification to Apple users. And likewise, Windows Notification Service, you can enter your package SID and security key, and Azure Notification Hub will be sending push notification to WNS. So likewise, we have multiple notification platforms. We have ADM, Bedu, we have Google. So if you see Google, which is FCM, Firebase Cloud Messaging, you need private key of your FCM application. You need client email and project ID of your FCM, and then you will be able to send notification using FCM. So likewise, you can see that Azure Notification Hub provides a unified API for sending push notifications so to all these platforms. For demonstration purpose, I will be using browser web push. So here we will be using this one. But for using this, so here we need to enter the subject name, and I need to generate Vapid keys. Okay. So now we will be using these keys for sending push notification to our mobile app. I need to enter subject name. So now click on save button. Okay, notification hub updated successfully. Now we will be using these private and public keys for receiving and sending notifications. So let's copy this Vapid public key, and I need to insert this inside my web application code. So, okay. So this is my Vapid public key. So you guys may be confusing about Vapid. So we can ask what is Vapid. So basically, Vapid or Voluntary Application Server Identification. This is a protocol which was introduced for standardized way to authenticate your server's identity to push services. Okay, so this is a voluntarily service for identification. There is no
But your
third-party
screen
service
is not moving.
involved for sending these push notifications. The browser own services
Habib,
like
can you hear
or
me?
Mozilla Push will be used for this service.
Habib, can you
So
hear
this
me?
is
Yeah, your screen is not moving. I think your screen sharing stopped.
okay. Okay, let me stop my camera and let me start my screen again. When does this issue starts? Can you see now? Simon, is it working fine now?
Yeah, we can see your Azure portal. Yeah, you're inside production, mobile production. Now,
Yeah, yeah,
now
that's
VS Code.
okay. Okay, that's great. So here we need to provide Vapid public key. So now I will run this application. So I already have one extension inside my well code. So I will be using that. Just go to index.html file, right click and click on open with live server. Okay. So if I inspect this service inside console, okay. So currently here you can see that notification permission denied. Basically, let me open this inside my Chrome. Okay. So if I inspect this and console, so here you can see that I already have granted the permission. So notification permission granted. Then service worker registered for this as well. Okay. And if you want to see your service worker, you can go inside application, and here you can see that service worker.js is already. So I was using this before, so that's why it is already registered. Let me refresh it again. Okay. So now if you see our service worker is running in background and this is activated. So this service worker will be used for showing push notification in background. And if I see the console, so notification permission was granted, service worker was registered, and user is also subscribed. So here you can see that this provides me endpoint, which is basically FCM endpoint. And then we have few keys as well for sending push notifications. So now we will be using these keys for sending push notification from our ASP.NET Core app to web browser. So let's go to Visual Studio. I already have created one push notification service for this. So here, basically, you need one library which is lib.net.http.webpush. So you can install this from Nugget Package Manager. And after that, you need a push service client. So you can authenticate this using Vapid authentication. And here it needs public key and private key. So let's update these public and private keys because I have created a new instance. I already have public key, so let's update this. Here is my public key, and here I need to provide private key. So let's copy that as well. Okay. So after this, creating the push service client, we need Vapid authentication, and then we will be using as a default authentication for this Vapid authentication. We have a send notification method. So this send notification method is getting a push subscription object and a payload. A payload is basically JSON that we will be sending to the user. I already have integrated this with my home controller. I have created a send push action, which is HTTP GET action. And inside this, I have injected a push notification service inside my constructor. So you can see this. And then I'm calling send notification async. And now here I need to provide few details. First of all, I need to send or I need to provide the endpoint which I have received after subscribing the push notification from my browser. So I have to update this. Currently I am doing all this manually, but for your real application you have to do this automatically because Vapid is independent platform without any service, so you have to manage all these things manually. So let me update these values from my browser. So here I need to copy the endpoint first. Endpoint is basically FCM endpoint where my push notification will be sent. I need auth key. Let me update it here. And then at the end, I need P256 DH key. So these keys are for sending push notification. Okay. So now these keys have been updated. Let's run my application. This is basically empty ASP.NET Core MVC application that I have created using Visual Studio. So you can create this and then you just need this code for sending push notification. Okay. So here this is. Let's click on send push. Okay. So now you can see that I just have received one push, which is test notification. This is the title of push notification. This is hello world. If I send it again received. Let me update the body of this push to see whether it is working fine or not. So I can say hello world from Azure notification hub. Let's run it again. Now click on send push. So now you can see that the body of notification is hello world from Azure notification hub. And this notification is receiving inside Google Chrome. So this is how you can send rapid push notification to your web application web push. I will comment and push this code to our existing GitHub repo, so you guys can access this code for demonstration purpose. Okay, so let's come back to the slides. So this was how we have created Azure push notification or Azure notification hub service inside Azure portal. Then we have created a web application which is receiving the push notification, and then we have created an ASP.NET Core MVC application which is sending the push notification. So now let's go to slides. So let's go to slide. Simon, can you please move to slides? I'm waiting for Simon. Okay. So this was hands-on demo. Uh, okay. In next episode, we will talk about real-time communication with Azure Signal or service. So in this is basically episode 14 of Azure Essential series. We will dive into the Azure Signal or service, which is a managed service for adding real-time web functionalities to your applications. We will discover how to leverage service hours capabilities to enable server client communication with ease. This episode is designed for web developers, app developers, and solution architects who are looking to implement dynamic, responsive, and scalable real time features in their project. So, thank you so much for watching this episode of Azure Essential series. If you are interested to watch the previous episodes of our show, you can access it from C Shop Corner /live/ Azure Essentials. You can see the URL in your slides. And if you are interested to access the code, you can access my GitHub repo, Habib Developer /Azure Essential series. And thank you so much again for joining this episode. And for thank you for being the part of C Shop Corner Islamabad chapter. See you in next episode and have a good day. Bye bye.